Welcome to the Aging YouTube channel. This interview is with Dr. Gil Atzmon in the Department of Medicine and Genetics at the Albert Einstein College of Medicine in the Bronx, New York. They are also in the Department of Human Biology and a faculty member of the Department of Natural Science at the University of Haifa in Haifa, Israel. They are talking about their manuscript published in Volume 9, Issue 1 of Aging, titled The Complex Genetics of Gait Speed, Genome-wide Meta-Analysis Approach.
So the paper that I'm talking about is the complex genetic of gait speed genome-wide meta-analysis approach. And what we did here is to combine 21 studies around the world and try to figure out what is the genetic predisposition for gait speed. The idea was that if we going by number, then we will find something because, the size is a matter of the resolution that you can pinpoint the genetic variant that might has effect on the phenotype that in our case is gait speed. So when you're talking about challenges, think of you have 21 people or 21 groups that you need to combine together and figure out how you harmonize the data that they provide you with and try to figure out what's going on there. This is a challenge because it lasts for almost 4 years until we had the paper done and published. But eventually what we find was great. Although what we expect to find once we started this endeavor, we thought to have variants that are genomic significant, meaning if you have this variant, either you have a lower gait speed or you have higher gait speed or normal gait speed, and we're talking about elderly people. That's what we tried to figure out, and we found out we didn't find such a variant, but we find other alternative. We try to use protein analysis, group analysis, pathway analysis, and all kind of stuff. And every time that we put the finger on such different analysis, we found something, some other interesting views. As I said, for genetic variant, we didn't find any, meaning we have the closest that we have was 10 to the minus 7 when the threshold was 10 to the minus 8. But when you look at these genes, we found that there are a couple of them that have higher prevalence amongst the top heat. Again, they didn't reach significance, but the minute you have such a number in the top heats, you think it might be relevant. So we have such a HLA-DPB1, we have the POM 121L2, and so forth and so forth, and you can see the paper to look to those variants. The interesting idea or interesting observation was that there was some couple of hits that we saw only once, but the other hits, such as the POM12IL2, we saw like a peak, meaning there is aggregation of couple of hits around this gene or inside this gene. Again, it tells us that this gene might be relevant to what we are looking for. When we did the pathway analysis, we find a couple of them that are associated with diabetes, which, if you think about it, diabetes can cause people to either slow gait speed or higher gait speed. It depends on the disease that you have. We have a couple of hits in the pathway analysis link us to cancer. And again, the same thing, if you think about it, the minute you have a disease, your performance, in this case it's gait speed, is either decline or increase. So we can see in both cases, although we didn't find the right hit, still what we found has some biological explanation. We also did expression analysis or expression QTL. QTL, it means that those genes that are associated with the expression of the genes that encoded the phenotype, we found a couple of them that were higher significance. Again, another example of what is the predisposition of those genes to the phenotype that we had. So all in all, we concluded, or we found some relevant genetic predisposition for this phenotype. And although we didn't find the exact variant that can, say, if you have it, you have low speed, and if you don't have it, you have a higher speed, we think that if we looking at the story that we crafted, we think that we found some ideas, some biological explanation to or what is inside this paper.
Aging was launched in 2009 and is currently a traditional peer-reviewed journal with free access, which publishes in monthly issues. Topics include high-impact research papers of general interest and biological significance in all fields of aging research, as well as topics beyond traditional gerontology. You can click on the link in the description below to order a reprint or read the manuscript that was discussed in this interview on aging-us.com. Please feel free to subscribe to our YouTube channel and connect with us on Facebook, Twitter, or LinkedIn. Thank you.